Hello AP Stats students, Mr. Hazelhurst here with your Chapter 7 Section 2A video. We're going to spend half of the information, or give half the information here in video. The other half we'll take care of through lecture and class. But in this video we're going to talk about the means and variances of a discrete random variable. So if you think back to the first video that covered Chapter 7, we talked about discrete and continuous random variables. So what we're focused in here on are the discrete random variables, the probability distribution of those who are represented by a table. And so we're going to talk about how to find the mean, the variance, and then ultimately the standard deviation. So we're going to start to mix in some statistics with our probability work here. So let's jump right into it. All right, the mean of a discrete random variable. So again, discrete random variable, it's got a table. All right, all we do to find the mean is we just simply take each x value times its corresponding probability, and we're going to add those all together. All right, and if you take a look, we're using that symbolism for the mean. And notice what symbol of the mean we're using. We're using a mu, not an x bar. So this is representing a population mean. This mean refers to the entirety of the table. And this formula is also found in your gold packet. So it's not a formula you need to memorize, just a formula you need to know how to use. Okay, but this is a very important formula in statistical work. If you think back to the video that we watched to start out Chapter 6, and the guy talked about how probability had its roots in gambling. And this is really one of the first concepts that really kind of came out for probability, is the mean of a random variable. Because it corresponds to what we refer to as the expected value. What do you expect to happen in a situation? Right? So this is oftentimes used in situations involving money, whether it's gambling or business. All right, we can find the amount of money that is gained or lost, the key here, on average over the long run. All right, so X would represent the amount of gain or loss. All right, what's the amount of money that we take on in a given situation? And so that's exactly the type of question we're going to use for our example here today. Right, we're going to verify or use this formula in the context of a gambling problem. All right, but the key again that we want to point out, we first need a table, and then we can do the actual work. All right, we'll multiply the x probability by its corresponding p and add them all together. So let's jump right into it here. So here's our example. Hopefully you're not following this cartoon already. So great Dilbert cartoon. Says the best way to make this decision is by calculating the expected value of each possible outcome. You multiply that, and then he says, must pretend to be dead. I sense that we're done here. So hopefully you guys are not playing the part of the pointy-haired boss and pretending to be dead. So wake up. Let's go. All right. So here's our example problem. All right. So as a tri-state pick 3 game, you select a 3-digit number. The lottery then selects a random 3-digit number, and if your number is selected, you win $500. Right? And it costs $1 to play. So what is your expected value? So the first thing we want to do is we want to list out everything that can possibly happen in this given situation. All right, well, in this case, it's really pretty simple. You either win or you lose. All right, now, win and loss, those are not numbers, so we're not going to represent those on the table. What we need to represent is what the actual transaction of money is. All right, so let's start out if you lose. All right, if you play this game and you lose, what are you out? Well, you're out $1. You're out what it cost you to play. All right, so we're going to represent that with a negative $1. All right, that represents a loss. Then the probability, or then we win. Right? Well, if we win, what's the outcome? We might say, well, we gained $500. Right? Well, yes, we won $500, but don't forget that it cost us $1 to play. So what we need to represent is what's our net gain? What do we actually end up making here? And really what we end up making is $499, right? They don't give you your dollar back that you spent. They give you $500. Well, you already paid $1, so your profit is $499. All right, now we need to know the probabilities of each of these occurring. Well, they said we're going to select a random 3-digit number, right? Well, how many different 3-digit numbers are there? Right, there's 1,000 of them, from 000 to 999. All right. So the probability that we win, there's only going to be one winning number. So that's 1 out of 1,000. The probability that we lose would be 999 out of 1,000. All right, so that would be our probability distribution representing this gaming situation. So now, according to the expected value or the mean of a probability distribution, all we're going to do is simply multiply the x value by its corresponding probability, and then we'll add them together. So a -1 times 999 out of 1,000 would be a negative 0.999. And then a positive 499 out of 1,000 would be a positive 0.499. So if I add these two values together, my expected value is a negative 50 cents. Now, what does that mean? That means on average, if I play this game continually over a long period of time, on average, I'm going to lose 50 cents per play. Okay? Now, does that mean that everybody who plays this game loses 50 cents? Think about it, no, right? A lot of people lose $1 and somebody wins $500. But on average, the average of all those players is a loss of 50 cents. Right? If we're dealing in a gaming situation and we end up with a mathematical expectation that's negative, that means that that game favors the house or whoever is running that gaming situation. If we ended up with a positive mathematical expectation, well, that means it would favor the player. And chances are you calculated it wrong because there's not a single mathematical expectation for any probability that would come out to be positive. If that was the case, casinos wouldn't make money, lotteries wouldn't make money, and they wouldn't be around. All right? So that is our mathematical expectation. Now, I might get lucky and win the very first time that I play. So then for me, I'm up $500, and I might not ever play again. All right? But that's just one play. All right? Again, when we think expected value, it's on average over the long run, and we don't want to forget that important fact. All right? So hopefully you see finding the mean or the expected value is a very simple process. All right? So let's talk about the variance next. All right, here's the formula for the variance. Again, this formula is located in your gold packet, but chances are if you're going to calculate the variance, you're going to do it the same way here in Chapter 7 that we did in Chapter 1. And we're going to use our graphing calculator to find the variance. Now, the one thing that I do want to remind you from this slide is remember the standard deviation is the square root of the variance. So that will be important to keep in mind. And again, I want you to point out the symbolism here. We're using that lowercase sigma symbol, kind of looks like a cursive O. So that means this is a population. And we'll want to use the same symbol on our graphing calculator. So let's just jump right into an example problem, and we'll show you how this all works. Okay? So here's our example problem. We've got some information about the probability of a certain number of cars being sold on any particular day by a certain salesman. Okay? So this car salesman is going to sell somewhere between 0 and 3 cars. And the probability of each of those things occurring, you can see, is listed out. All right, so we want to find the mean and the variance. Now, we know the mean would be very easy. We just take x times p of x and add them all together. So we can do that by hand really easily. So let's do that real quick. All right. So if I wanted to find the mean again, we just multiply and add. So this would be 0. Multiply these two together, we get 0.4. We get 0.4, and we get 0.3. And when we add those all together, so on average, this car salesman can expect to sell 1.1 cars per day. Okay. So that's how we find the mean. Very easy. Well, let's do this on our graphing calculator. Okay. So notice the first thing that we need to do is we need to input the data into the tables or the lists in our graphing calculator. And we're always going to enter the x value. So in this case, the number of cars sold will go in list 1. And then the probabilities of those will go in list 2. And we need to make sure that we keep them in the proper order and they match up. All right. So let me pull up my graphing calculator. I already have things input here. So we can, put that to work. All right, let's slide it over here so we can see those steps so you can kind of follow along. All right, so if you take a look here, first off, I already have all the information input into list 1 and list 2. All right, so the next thing I want to do is I'm going to exit out of this screen, and I want to run the one variable statistics. So I'm going to go stat, scroll over to calc, and my one variable statistics is right at the top. And I'm going to tell my calculator to use L1, that's my list, and the frequencies, which would be the probabilities, are represented in list 2. And we'll hit calculate, and there it comes. Now, first off, notice the top symbol, right? There's our mean, same mean that we calculated by hand of 1.1, right? And notice that it gives us the standard deviation. Notice it's the same symbolism as we saw on the formula for the variance. So the standard deviation is 0.943398, right? So standard deviation is a little bit less than 1 car per day. Now, if we wanted to find the variance, right, off of our calculator, remember we would need to take this number and square it, right? Remember the standard deviation is the square root of the variance, so if I want to go the opposite way to find the variance, I need to square it, okay? So very, very simple, all right? And if you're asked to find the mean or standard deviation, this is going to be the process that you use to find the mean and standard deviation. We'll do it on our graphing calculator. It's the easiest and fastest way to do that. Now, the other thing that I want to show you at this point is how we can also create a probability histogram on our graphing calculator. All right, so I've already got that data input into list 1 and list 2. So if I went into my stat plot and I set up a histogram, right, so I'm going to choose the histogram. I've got list 1 and list 2 input as my X data and then the frequency of each of those. All right, and then let's say we hit zoom 9. Well, this doesn't give us a very good picture of our probability distribution. All right, we know there were 4 X values, 0, 1, 2, and 3, represented here, but those don't show up real well the way that this is set up. So what we need to do in these cases with a probability distribution, if you want to create a probability histogram on your calculator, is we're going to go to the window menu, all right, and we're just going to set some things up based on what we know about this distribution. All right, so on my x-axis, well, I know that the smallest x value I have is 0, so I'm going to leave the x-min at 0. The largest x value I have is 3, so I'm going to change the x-max to 3. And on the X scale, well, when I look at my values in that table, all right, they were going up by 1. So I'm going to set my scale to do the same thing. We'll go up by 1. For the Y minimum, remember the Y-axis is representing the probabilities, right? So I'm going to have probabilities from 0. Now in my table, the largest probability was 0.4. So let's say we go up by 0.5. That's our maximum. Right? And let's have our scale be set to 1/10 of a unit. This means the tick marks on the y-axis would be 0.1, 0.2, 0.3, 0.4, and so on, which would match up great to the probabilities that I have. And the rest of these numbers down below don't matter. But if I can set the x-axis scale and the y-axis scale to match up to my table, when I hit graph now, don't hit zoom 9. If we hit zoom 9, it's going to change these values. All right, we just want to hit graph. And that gives me a great picture of that probability distribution. Now, hold on here. I didn't set something right. What did I not set up right? So we got 0 to 3. Oh, we need to go 0 to 4, excuse me. And then we'll hit our graph, and there we go. So we've got from 0 to 1, 1 to 2, 2 to 3. This is my problem on the first graph button I hit, is we weren't seeing that 3 bar up here, which would be above 3. And now notice how things work out great. If I use my trace button, notice how my values match up. All right, so the probability that we're in the 0 range is 0.3, that we're in the 1 range is 0.4, and so on. And we get a much clearer picture of that probability histogram. So we talked about probability histograms yesterday, but since we have our graphing calculator pulled up today, I thought it'd be a good thing for us to show you. All right, so that is how we find the mean and variance in a discrete random probability. So pretty simple, okay? Now, one important concept that we need to bring up at the same time is the idea of the law of large numbers, all right? And this is a very important statistical concept, all right? It says as the number of observations drawn increases, the mean of the observed values eventually approaches the mean of the population and stays close to that value. What this goes back to is that idea of the expected value, right? When we calculated the expected value of that game's expected value came out to be a loss of 50 cents, right? Well, it's actually impossible to lose 50 cents on a given try because you're either losing $1 or you're gaining 499, right? So if we played this game over and over again, right? We might lose a whole bunch. So on average, we're staying at a -1, right? But then eventually, over time, at some point, we would have to win. So as we calculate in that win of $500, that's where that average is going to start to change. And over time, over the law of large numbers, over a large amount of data, we're eventually going to get close to what that true expected value is, right? The way I like to think of it is think of flipping a coin, all right? How many heads would you expect to get if we flipped a coin 5 times? Well, on average, right, we would get 2.5 heads. Well, it's impossible to get 2.5 heads. But over time, on average, it's possible, and that's going to be what happens. That's the idea of the law of large numbers. Now, what we need to understand, we do have a law of large numbers, but we do not have a law of small numbers. All right, if I flip a coin 4 times and all 4 flips result in a head, does that mean a tail is any more likely to occur? Well, no. You might think, well, it needs to balance out eventually. That's true, but that's going to happen over a large period of time, right? We're not going to flip a coin 20,000 times and end up with 20,000 heads. It's possible, extremely unlikely, but possible. All right, so remember, when we talk about probability, when we talk about chance, and this goes back to the video that we watched, it only describes outcomes that happen in the long run, over time, with large amounts of data and large amounts of people. But we can't take that law of large numbers and apply it to a single event. That's the challenge of probability. All right, well, here's one more cartoon to finish out. All right, great example of the law of small numbers. It says over here we have our random number generator, and the random number generator is just saying 9, 9, 9, 9. It says, are you sure that's random? It says, that's the problem with randomness. You can never be sure. Right? We're seeing a small glimpse of that random number generator. Right? For all we know, as soon as we walk away, he's going to start spewing out different numbers, and it would start to follow the law of large numbers. But in this small snapshot, we just can't know. All right, well, again, a reminder, complete that form at the bottom of the video. Leave any questions, concerns, or thoughts you might have from anything that you learned today. And have a great day. We'll see you soon.